So, you've got a working Python app. Congrats! But now you need to run it somewhere. You can't leave it running on your computer all day long. How about we run it on a Raspberry Pi instead? Hey there, I'm Elliot, a software engineer working in the UK, and I'm here to share with you some of the things that helped me become a better developer. In this video, we're going to look at how to deploy our app to a Raspberry Pi using systemd. So here's our Pi, the Raspberry Pi 0W. The W denotes that it has wireless capability with Wi-Fi and Bluetooth built in. This only costs $10, so it's very affordable. And the only other things you'll require are an SD card and a micro USB charger, which you probably have already. To start, we'll install the Pi operating system image to the SD card. We can do this using Raspberry Pi Imager tool found at raspberrypi.org/software. You can find a version of the tool for most operating systems, including Raspberry Pi OS itself. Download the version for your OS and then open it up. It has a nice simple interface. We can choose which OS to use. I'm going to use the light version because we don't need the desktop. Then, with the SD card plugged into the computer, this will erase anything you have on the SD card, so make sure to save any important data you have on there beforehand. Hit the right button to copy the image onto the SD card and let it run. Once complete, it will tell you to take out the card. But wait! Before we do that, it's a good idea to set up the Pi for remote access, which saves us having to plug in a mouse and keyboard into the Pi itself. To do this, open up the SD card folder, which now shows up named boot in Windows. Here we'll create a wpa-supplicant.conf file. You can find a template for this file in the video description. Set your 2-letter ISO country code at the top and add your Wi-Fi network name and password next to the SSID and PSK respectively. Adding this file will let the Pi automatically connect to your Wi-Fi network when it boots. Secondly, to enable SSH, you simply need to add a blank file named SSH with no file extension. With both these files added, we can safely remove our SD card and plug it into the Pi. With the Pi powered on, we need an SSH client to connect to the Raspberry Pi. Now macOS and most Linux distributions have an SSH client already, but with Windows there's a few options. You can either use OpenSSH in PowerShell, or use a third-party tool like PuTTY, or as I'm going to do, use Windows Subsystem for Linux. A minute or so after powering on the Pi, we should be able to connect by typing SSH space Pi at Raspberry Pi. If you have trouble connecting, or have another Raspberry Pi on your network already, you may instead need to access the Pi using its IP address, which you can find by checking your Wi-Fi router's admin panel or using a tool such as Nmap. If SSH reaches the Pi successfully, you will be asked to confirm the signature. Type yes to confirm. Log in using the default password Raspberry, then as a minimum security precaution, change the password using passwd. It's also not a good idea to store the Wi-Fi password in plain text, so you can change this by running wpa_passphrase followed by your network name. You'll then be prompted to enter your passphrase again. Copy this new encrypted passphrase, Windows terminals copy and paste using right click, and then open up the supplicant file again using sudo nano/etc/wpa-supplicant/wpa-supplicant.conf and then replace the PSK value. Note not to have quotes around this new value. Close and save the file using Ctrl+X and press Y to confirm. That's some very basic security taken care of, although I still wouldn't let us anywhere near the internet. This is just my local network. Now with the basic housekeeping out of the way, let's get on with setting up our app. First we'll run sudo apt update to get the latest package definitions, and then we'll use sudo apt install followed by our package names to install them. Note that these will probably be required for most Python apps. This one is more specific to my project. With the dependencies installed, we'll clone our project from our Git repo using git clone, followed by the address that we found on the project main page. If your project is private, you'll need to add your SSH public key to your GitHub or GitLab account. Next we will create a symbolic link to link our project folder to the /opt directory using sudo ln-s $open bracket pwd close bracket / your project folder name space /opt. We can then cd into that folder using cd space /opt / project folder. If we run ls-a from inside this folder, we can see all the contents of our project. Now we'll set up a Python virtual environment. This is important as it prevents our project modules from interfering with overall system modules, as well as any other projects we might have installed. We do this using the command python3-m space venv space .venv. The .venv is the folder we'll be creating our virtual environment in. If we run ls-a again, we can now see we have the .venv folder. To activate this new virtual environment, type source.venv/bin/activate. You should now see a little indicator to show we're currently using the Python from the virtual environment. Typing which Python shows us the full path of the Python we're currently using. With our environment now active, we can install the Python requirements from the requirements.txt using pip install r requirements.txt. This will take some time, so you might want to go grab a drink or something. The final step is to create our service file. We can do this by typing sudo systemctl edit --force --full your service name .service. This will open a blank text editor. You can find a template for this file in the description below. At the top of the file we have a human-friendly description of the service and any other services that this one depends on. This middle section is the bulk of the configuration. We can set our environment variables, the working directory, and our commands. The ExecStart pre command will run first. I've set this to be a 10-second sleep to allow the Wi-Fi a chance to start before the main command runs. For the main command, I've added the full path to our virtual Python, as seen with the which Python command, and since I've set the working directory, my script is invoked by simply app.py. I've set the restart to be always, so if anything causes the app to stop, such as a crash or some error, it'll try and restart itself after 10 seconds. The final section means that this is a system-wide service and does not require anyone to be logged in. It will start as soon as the Pi is booted. After we close the file, we can enable it using sudo systemctl enable service name, and then we can start it immediately using sudo systemctl start service name. And would you look at that, BB8 has woken up. And there we have it. Our Raspberry Pi will now run as long as it has power. If you like this video, feel free to check out my other projects and tutorials. Thanks for watching and see you next time.